Okay, so so far we've looked at a couple of topics. We have looked at basically like brain functions, so the central nervous system, different parts of the brain, and neurotransmitters. Today, what we're going to look at is lateralization of function, different hemispheres of the brain. And there is a key study that you need to know for this part of the course, which is the Sperry study as well. So as you can see here, the brain has two different hemispheres. You have a left hemisphere and you have a right hemisphere. And we're going to talk about what the difference is between both, and how researchers use this information in psychology. So what this means by lateralization is you're going to hear this word lateralization a lot, and it means how some cognitive processes are more dominant in one hemisphere than the other. So for example, if you're doing a certain kind of thing, if you're cooking, for example, just because my wife's just making lunch now so I can smell the food. If you're cooking, for example, that might use one part of your brain more than the other. If you are trying to solve a maths problem, then you might be using one part of your brain more than the other. So the brain, it's almost, some people would say that we have two brains in one. So what you have is there's something in the middle here, this medial longitudinal fissure. So this kind of part here in the middle, that separates the two brains. So if I was, next time you don't do your homework, I was to open up your brain to see if it was located somewhere there, it would look something like this. So you'd have this thing in the middle, and you have the corpus callosum, which connects the two here. So they look this kind of the same. If you were to just look on the surface of the brain, both sides kind of look similar, but they're very different in terms of how they're organized. So this gives you some examples if you're left brain or right brain. So have a look at this list and then think to yourself, what are you? There's also the quiz. So I've sent you a quiz that also asks you these kind of questions, and it will tell you if you're more left brain or right brain. So people who are more left brain, they might be more like this. If they describe their personality, they might say more of these kind of things. They might be more analytical. They might notice more details. They might like to order things in sequence, and kind of think about rational thought. Maybe they're more scientific, more mathematical, and logical about how they do things. And also, it is to do with your motor skills. So if you how well you can catch something, maybe how well you do at sports, how you drive, all these kind of motor, how you play computer games. All of these things are kind of motor skills that work on your left side of the brain. The right side of the brain, this is about intuitive thoughts. If you see something, when you hear this phrase where people say they have a gut feeling about something, that's intuitive thought, something that comes to you. Holistic perception, so looking at everything instead of looking at finer details, it might be holistic perception. So I mean, I would say maybe I'm one of these people. I have people I know who notice very small details. They'll come to my house or my car, or I'll be talking to them, and they'll notice something, and I haven't paid any attention. They might say, oh, that painting on the wall, it's slightly it's slightly at an angle, or it's a bit wonky, and I would have looked at the painting, walked past it, and not had any idea. But there might be people who are very detail orientated. Maybe people in your own life, in your family, who look at particular details. On the other hand, you might look at things holistically. So you're trying to look at a bigger picture, but then you might miss small details when you're doing that. It's also the side of the brain that deals with emotional thoughts, your emotions, and your impulsiveness, your creativity. So if you're painting or drawing, for example, your right brain area is going to be, quite well activated there. And again, now when I talk about motor skills, sorry, I should mention here as well, your right brain controls your left side of the body, and your left brain controls the right side of the body. Yeah. So your brain hemisphere operates the opposite side of your body, which is kind of strange to think about, and it's a bit counterintuitive, but that will be kind of explained later on. Okay, so you can see in a nutshell what kind of things are left brain, what kind of things are right brain, and you do the quiz as well, and then you'll get a good idea for yourself, like what side you are and what side you're not. And before I move on to the next slide, I want you to make a prediction here. Let's look at gender, yeah, because we do look at gender a lot here. What's your prediction? So, guys, you can turn your microphones back on for this. What do you think is a typical male brain, and what do you think is a typical female brain? Well, let's start with where do you see?
I think the right side. I think the right side is like for female, and the left side is for the male.
Okay.
Because it's got like writing art, imagination.
So what makes that female, John? You're saying
because women are artistic. They are imaginative also. Some women are even emotional. What should I say?
Yeah. be careful there. So yeah, no, but this is what maybe many people would say is that the women are creative or artistic. There are more female artists or women who work in the arts.
But then it depends on the person, isn't it?
It does, absolutely. It depends on the person. There are individual differences here. Yeah. So all these things you could say a generalization about men or women, for example, but it all depends. Like, would you two agree that this is like how you would describe yourselves? So, John, for example, would you see yourself as more left-brained?
Yeah, you would, yeah.
Okay, Aisha, would you see yourself as more right-brained?
It's a bit mixed, like
a bit of a mix. So sometimes it doesn't have to be, exclusively that category. For example, I would say myself, I would probably be more right-brained, but there is a mix because sometimes I like to, put things in order, and you've seen with my Google Classroom, how I like to put everything in a nice order for you guys. But maybe that's not my way of working, but I think it's effective. But it could be a mix of different things. You might have some men who are more on this side, more right-brained. You might have some women who are more left-brained. But in general, this is what the argument is, that we tend to be like this. And there are evolutionary reasons. We won't go into lots of reasons, but there's reasons why humankind has developed in this way, why men and women have traditionally got to this stage. So what you tend to see as well is you have different visual fields. So you have basically what you can see on the right side, what you see on the left side of the brain. Like I mentioned, it kind of switches over from the side of the brain to what you're actually seeing, and there is a study that will demonstrate that as well. Language, for example, is left dominance, generally the left side of the brain, but plasticity ability is in the right. So this is something interesting, because if we go back here, because you'll see verbal ability, let's say, is the left side. So being able to understand language is a different thing to being able to, let's say, speak a language. Being able to learn a language is a different skill to actually speaking the language. So in some ways, for example, if we're going by this gender theory that women are better communicators, for example, it might be because they're better at learning languages. So in general, women are better language learners than men. So this would kind of make sense as well. There's plasticity. Yeah. What we mean by plasticity, imagine you have some plasticine, yeah, and you squeeze it in your hand, yeah, it means you can change the shape quite easily. And this, when we talk about how we learn things, we say if there's plasticity, it means that our brain is changeable. Yeah, we can change the chemistry of our brain. We can change the kind of things that we learn as well. Yeah, but you can see this. Look, with all, even with our nose and our ear, yeah, how this operates in terms of brain. The left ear is dominated by the right, for example. Yeah. So this is what we mean by this. You don't need to know this in huge detail, but it is useful to know. Okay. Now, what else do we know about differences between genders? The male brain is typically about 10% larger than the female brain. But does a bigger brain mean you're more intelligent? No. In many cases, people would argue the opposite. So the mass gives males more processing power. So that's all it really means. Maybe that men can process more information in their environment, but that doesn't necessarily mean it makes men more intelligent. The argument goes that maybe male brains are bigger because men in general are physically bigger. So they just, they need to fit this brain inside their big heads. Yeah, that's the only reason. But we know from the animal kingdom, just having a big brain doesn't mean that that the animal is necessarily more intelligent than another. Yeah, there are animals that have quite small brains relative to their bodies, but are actually very intelligent. I think some birds, for example, fall into this category. Yeah. So there are different examples of this. So as I mentioned before, men generally tend to be left hemisphere dominant. Women tend to be more evenly balanced between left and right hemispheres. So women actually have a larger corpus callosum. And because of this, that makes them maybe more intuitive, better communicators. And men generally are less socially adept and more task-oriented thinkers than females. Yeah. So these are general differences you see, but of course there are individual differences. Not all men and women follow this kind of pattern. Yeah. Language we spoke about already. Women generally excel at language because the language centers are generally bigger in female brains, and men tend to like using just one side of the brain. Yeah. So again, there is research support for this. And when we talk about emotions as well, there is a general stereotype that women are better at dealing with their emotions, but there is actually, cognitive evidence for this as well. Yeah, that again, the area of their brain that deals with emotions is activated, more often than in the male brain. The flip side of this is that actually it means that women are more prone to different types of depression and emotional disorders. They're more at risk of depression, of anxiety, of all manner of mental health issues than men because of this. Now, what are the kind of strengths of this kind of research? There are laboratory studies that look at this. For example, the Herasti study in 1997. There is support for this. Different male and female areas of the brain and language centers. But problems with this kind of research, you can't generalize, like we said. Yeah, you can't make this assumption for all men and women. Not all women have better language skills than all men. And actually, there is some research saying there is not a strong claim for this language function difference. So it might be a case that it's just personal preference, personal interest, in what you're doing. You could also say it's a historical thing. Yeah, if society and culture has changed, and we learned this in sociology, that maybe it's more acceptable for men to take interests in things that were predominantly female interests before. And obviously, if you practice doing something again and again and again, your brain, your brain essentially changes. It becomes more plastic because you're doing that and you're better at that skill. So that brain area is going to be activated more and more. So it might be just down to our experience and not because we're born with a certain ability to do something. So what has happened previously is that the corpus callosum, fibers in the corpus callosum are cut by surgeons. So if someone, for example, has epilepsy. The epilepsy, is again a neurological condition, and things like, for example, lots of flashing lights or very fast-moving flashing lights will set off epileptic attacks. And it's a very serious condition. People can actually choke on their own tongue while they're having this seizure and lose consciousness. So it's quite a serious condition. So what happens is, let's say, some doctors are able to actually cut a certain part of the brain that deals with this because there is an imbalance between two hemispheres. So surgeons have found that actually, if you do this separation, the seizures are not as bad, they're not as severe for the person who has epilepsy, and there is ultimately less damage to that person that's given. So we'll move on here to the Sperry study. So this is the key study that you're going to be looking at in in this part of the unit. And so the Sperry study itself, what Sperry is looking at is hemispheres have different functions and abilities. But each hemisphere has its own awareness and its own memory. So first of all, they looked at this. It was a natural experiment. Okay. So what is the opposite to a natural experiment, guys?
Lab experiment?
A lab experiment, yeah, absolutely. So in this sense, so what are the kind of advantages of, why would you do a natural experiment rather than a lab experiment?
Natural experiment.
Maybe it's more reliable. It's more like.
So the
Is
natural
it like,
would be more reliable.
I don't know how to word it. Like,
I think, well, maybe not more reliable, but it could be more valid, yeah, because it would be what people would do in real life, yeah, rather than just a laboratory setting. Because people in a laboratory setting, what might they do? Would they behave the same way as they would in the real world?
No.
Not necessarily, yeah. They might change their behavior in a lab setting, yeah. Okay, so they had 11 participants. Does that sound like a big number?
It's okay.
no, not.
It's not a huge sample, is it? It's a small sample.
No.
They were all epileptic, so all of them were male, and they'd all had this surgery. Okay. Any other issues you might see with this study, with the sample?
They're all males and they all have the same surgery, so it's not like it's the same throughout. So the results will mainly be the same.
It's a very specific sample, yeah. So you don't have any female participants in the study, but all of them have done the surgery. That's also a good thing, yeah. So you have you have the people in the study who have gone through the same procedure. So actually, there is this element of fairness and some kind of reliability to it as well. Okay, but always be thinking about this when you're uncovering research. The procedure. So what actually happened in the study? You had the participant. They had one eye covered, and they had to look with the uncovered eye at a specific fixation point. Basically, something was projected to them. They covered one eye and they looked at something, on the other side. If you've ever had an eye test at an optician, it'd be something similar to that, where they might give you things, and again you have to kind of look through one eye. But the slides were done very fast. So one picture every 10th of a second. So basically 10 pictures every second. Why do you think they did it so fast? So what the participants had to say, or what they saw, yeah, they had to say what they actually saw. So why do you think they did it so fast?
Maybe it's just memory because they go through the surgery, so to see if the memory is good or like they can see right.
So remember, they're not testing memory here. They're necessarily. They're testing again, what they've seen, not necessarily long-term
Oh, is
memory.
it the brain side? So like if one's eye is covered, then they see like the side. That's what.
Yeah, so I mean that is what they're doing. But if they were to do this much more slowly, yeah, there's more time for the participant to actually remember and react. So it might be not testing what they're supposed to test. Yeah, that's why they had to do it quite fast to make it a challenge for the participant. Okay, so what they would do then, they would give them. So the first they had this visual stimuli test, so they had to look, and then they had a tactile stimuli test. Tactile means they had hidden objects, either on their left hand or right hand or both hands. So what they had to do was they had to feel and they had to identify or draw these objects with the opposite hand. So you can see the picture here. For example, you can see here, let's say you had someone picked up a key on the left hand. Yeah. But then would have to identify on the second opposite hand, yeah, or draw what the key was. Okay, so never with the same hand. So what they found was that the images and objects are only recognized when they're presented to the same eye or hand. If an object is displayed on one half of the screen and then on the other, then the participant doesn't remember seeing it before. So it shows you again how the brain works and how these two hemispheres work. The key important conclusion that they came to, that Sperry came to, hemispheres are independent in terms of perception, awareness, and memory. So basically, it's like having two brains in one. If your left side of the brain was involved in doing something, the right side of your brain will not remember it. So it's a kind of a very interesting study here. And again, look in the textbook to kind of go over the details again. But this is essentially what it's saying. Yeah. If this person was picking up the key or the number or the plate on one side, then having to draw it or write it down on the other, they would struggle to remember it. It would be very different. Okay. But again, we mentioned what's some issues with the study. This was only 11 people that they studied this with, and they all had this same surgery. But even then, we don't know how severe the surgery affected any of them. How well did they remember these things beforehand? What was their cognitive ability like before this surgery? How would a sample of female participants do in this kind of study? Yeah. And again, would this be naturally occurring for someone who didn't have any brain damage, who didn't have epilepsy, for example? Okay. But let's see, how else would we evaluate this? It was a natural experiment. Yes, the researcher couldn't manipulate the groups. Yeah, they all had severe epilepsy. We didn't actually get a control group, so it would have been interesting. Let's say if one of us, for example, who doesn't have epilepsy, if we were to do this study, how would we perform on this task?
Yeah, that's what I was gonna say. Like at the beginning, like because so many studies test like with a participant without anything. So wouldn't that be a strength if they did that?
Yeah, if they had a control. Yeah, so they didn't have a control in this study. So that would be a weakness of the study. If you had a control, that would be something beneficial. You could compare, because it might be that any of us, we would perform, maybe we would perform similarly or worse or better. That can give you some more information, yeah, on your conclusion. It was a small study, only 11 patients. And it was a very specific task that they were given as well. So you can't generalize this to everyone. Maybe this is more to do with their epilepsy than it is to do with general brain function. And how ecological is this? What we mean by ecological, the clue is in the word eco, in the real world. So does this actually happen to us in the real world? Do we just see something on the left side of our brain or the right side of the brain? Generally, when we're walking around or we're doing things in the real world, both areas of our brain are being used. Yeah. Or if we don't see something on the left side, we don't see something on the right side, we can basically just move our heads, or move around just to make sure both sides of the brain have witnessed, what we need here. So both hemispheres are still in the same body, which do and see the same things. So in this sense, maybe there's a problem of ecological validity. Is it reliable? It's a natural experiment, so maybe we can't control all of the variables, right? So how people were, what was their mental ability before the operation? But at the same time, they were doing all the same tests. So that was controlled at least. How useful was the research? Maybe there are implications for helping people who have brain damage. So actually, this could be quite useful if people who have epilepsy or other types of brain damage, this kind of study can show them, actually, look, this might be, you might need to train and do particular kinds of tasks, or maybe you're going to have difficulty doing certain kinds of things. And again, as we mentioned, generalizations. It's very limited into how you generalize this, because actually the other thing, I don't think I mentioned this, all of them were male and right-handed as well. And split brain patients are generally a minority. What you find is actually there was a generation of people, maybe my age, slightly before my time, who would have naturally been left-handed, would have written with their left hand, but at schools at the time, teachers and parents, discouraged this. They thought it was kind of wrong to be left-handed, and it was something it shouldn't be done. So a lot of people were actually, forced to write with their right hand, to do things with their right hand. Whereas now that's not the case. Some people are naturally left-handed, and will do that. But what a lot of research suggests is that people who are left-handed, again, use different parts of their brain. They have different areas that are activated. You also find this in sports. People who are left-handed in sports generally are seen as quite creative, on the football pitch or on the tennis court or wherever they are. They're generally harder to play against those kind of players than right-handed players. Although you can't generalize this to everyone. I'm left-handed and I'm hopeless. So it's not everyone that this applies to. But again, those are some examples from general life. So this very study, this is one of the key studies. You're going to be asked about this in the exam. You need to make sure you know all of this quite clearly. You've got the PowerPoint here, and you've got the textbook, and that should be enough information for you, to go on. So then next week, what we're going to look at is neurons and synapses. So that will be the next topic. Make sure this week you go through all of this and you're clear on exactly what you need to do. Okay, so I'll just end it there. And if you have any other questions, just type it in the. Well, actually, do you have any other questions, guys?
Not really.
We're all good. Okay, so I'll leave it there.
Yeah,
Go through the workbook. Make sure you've gone through the workbook questions for this week, and start filling those in. So, John, make sure, I haven't seen those in your workbook yet, so start filling those in as well. Yeah.
Sorry.
So there are some questions in the workbook. So just fill those in as you're going along.
Oh, okay, that workbook. Yeah.
Yeah.
Sure.
So everyone has a copy, so you can fill yours in, and I'll see that.
Okay.
Okay.
Yeah. Okay.
All right, guys. The recording will take I think maybe 10 minutes before I can actually upload it. So it'll be ready by the end of the lesson. But in between, just send me a message on chat if you want to ask anything. Okay.
Okay. Well, I've got a question. It's not about this. It's about like the report,
Yeah. What's the question?
For sociology, like the subject, what do you think I'm going to get as my report, like the grade?
I mean, they'll be coming out soon, so you won't have to wait long. If you really want to know today, I can send you my report.
Yes.
You want to send it?
Yeah.
Wait,
okay.
what do you mean, our school report?
Well, your school reports are pretty much ready. So Mr. Linder is going to send these by the end of the week. If you could, I think by the end of the week. If you can wait until the end of the week, you'll get all your subjects. If you want just for sociology, then
I just want to know what I got, and then I'll just check my report at the end of the week. What did I?
Yeah. So guys,
absolutely.
With reports, I want you to actually read the comments. Yeah. Don't just look at the grades.
Okay. Yeah.
My parents made me just look at the grade. They look
I know
at the
what-
comments obviously, but after the grade. Like,
Well, see, okay, I might be mean here then. What I could do is I'm going to send you the comments. I can send you the comments, but I won't send you the grade because then
Oh no.
that's the only way that
or
you're
if you
my-
grade the grade and send the comment.
well, that's the only way that you're going to read the comments. Otherwise, you just ignore them and you'll just go for the grade.
I'll
But you'll
read them if you tell me the grade. If it's like a little grade.
well, look, seeing as you guys are here, I'll send it across. But please read what I said. Yeah. I'll
Yeah. Okay. I will.
share them with you now. Okay. All right, guys. Yeah, and then just but focus on psychology now. Yeah, and then look at
Yeah.
that later. All right.
Yeah.
Okay.
Thank
So
you, sir.
I'm here. Send me a message if you need anything. And if not, then I'll speak to you guys again on Tuesday. Yeah.
Okay.
Okay.
Yeah.
Okay. Cheers, guys.
They both left. They all left. Wow. But to be honest, it's fine.